Hi everyone, and welcome to QBranch's video on making decisions about motors and gear ratios using the JVN Calculator. This is Burdett, and in this video I will be walking you through a few common uses of this calculator and how we can use this tool to make decisions about a robot design. For those not in the know, this spreadsheet was developed by the lead mentor of FRC Team 148, the Robo Wranglers out of Texas, and he also happens to be the lead of VEX. There's also a Doctorate of Engineering thrown in there somewhere, and a Woody Flowers Award somewhere in there, and so this guy knows these spreadsheets like it's nobody's business. So I'm going to trust that he knows what he's doing. Often when we want to motorize an action in FRC, we have to reduce the speed of the motor and also increase the torque to make the thing move how we want it to. This spreadsheet, which can be downloaded from the link at the bottom of the screen to figure out what ratio we want to use, how fast this thing is going to make the robot do its thing, and how much current that will draw. If you haven't already done so, go ahead and download the file from the link and open it up in your Microsoft Excel, OpenOffice, or however you open up spreadsheet files. You'll notice along the bottom that there's many different tabs with many different labels. Each of these correspond to a different basic design, like rotary arm, linear mechanism, while others correspond to specific driving gearboxes. Let's start by clicking on the tab which says VEX Pro 3Sim Ball Shifter. This is a very specific gearbox made and sold by VEX Robotics. In here you can change what kind of motor setup you're using from a 2-sim, which is a very common configuration, to 3 mini-sim or any other combination. As you change the type of motor, you will notice other numbers on the page changing as well, specifically those that are in red. What you want to pay attention to is the speeds of the drivetrain. Most FRC robots can be driven from 12 feet per second up to 16, so you'll want to keep your high speed in this range. A skilled driver can handle up to 20 feet per second, but rarely is this level of speed necessary in the challenges. The low gear in this case is up to you, and this is changed by the middle section which says the spread. You can also change the diameter of the wheel, which will also change the speed of the robot. So play with this to know what is best for your design and gameplay. Once you found your choice of wheel diameter and gearbox ratios, you may wish to purchase those gearboxes from VEX, or perhaps just the gears themselves if you have made your own. Next, let's try making decisions on a manipulator using the spreadsheet. So let's suppose we have an arm we want to move through different angled positions. In FRC, we want to move between positions as quickly as possible to get a game piece and then score that game piece. Our limits on this are the amount of amps of current drawn to do so and the mechanical strain of the chain or gear or whatever is used to move the mechanism. So let's suppose we've got a 12-inch long arm with a 3-pound weight on the end. So you're going to input that data in the spreadsheet as I'm doing here. What we need to look for are the red numbers in the quote arm time to move 90 degrees and the quote current draw per motor that is loaded. Your goal is to get the time to be as small as possible while keeping the current draw below 30 amps. You can go to 40 amps if you connect to the 40 amp slots on the PDP, but these will be in short supply as likely your drivetrain motors will be taking up these slots. So change the motor and change the gear ratios to make this work for you and your design. Keep in mind that a versaplanetary gearbox should not be used beyond 2 stages, and that the 10-to-1 ratio is susceptible to strip, and you can include the number of teeth on sprockets or pulleys as another reduction stage. There is no one right answer here, but this is the general goal of using the JVN calculator. Then you can buy the ratios in a smart, informed manner. Alright, that's it. So good luck, have fun, and thanks for watching.